Okay, Assalamu alaikum. So continue from where we left off. We did the basic algebraic integration when the function had a power n. Now we'll be continuing it to exponential. What about exponential differentiation? If I tell you to differentiate e to the power x with respect to x, what do you get? E being the Euler number. What do you get when you differentiate e to the power x with respect to x? We say e is a special number, so that we again get e to the power x. Exponential and the power remains the
And
same.
it's a multiply by 1.
Yes, we do not need to do that. We do that when there is a function. So again, if I repeat it, integration being reverse differentiation, what can I say? What will be the integral of e with respect to x? Now we are well aware of the notation of integration. So what will be the integral of e to the power x with respect to x? It will again be e to the power x plus c. Do not forget the arbitrary constant. Is this clear?
Yes, sir.
So this was the easy part. Okay. What if I have e and there is a function in the power? I need to differentiate it with respect to x. What do? We have understood it using the chain rule that the power remains as it is and the entire thing multiplies by the derivative of the function, right?
Yes, sir.
So if I were to break it down, I'll say that the exponent or the power remains as it is. Remember, when power is a function, right? And it is multiplied by the
Discriminant of
derivative of the power,
power.
right? So what if I have to integrate e and it has a function in the power? So let me just write it e and there is a function and I need to integrate it. How do I do this now? Integration is the reverse process of differentiation. You can go back. What do you get? E to the power fx. Power will remain as it is. Now you will divide by the derivative of the function. Is this clear?
Yes, sir.
Again, mostly you'll get a linear function in the as the power, so that will be easier to integrate. Let's do a few questions from exercise 15.4. Okay. Now, how would we integrate these three integrals? E to the power 5x and it will be divided by 5 plus c. Is this clear?
Yes, sir.
What about part B? I hope you're writing everything down. What about part B? E to the power
9x upon 9
and plus c. Do
plus
not
c.
forget the arbitrary constant. What about this one?
Sir, upon 1 upon 2 plus c.
Okay, is there a better way to write it? Yes, I can write it as 2e
2e power divided by
plus c. So
upon
instead of
2.
dividing by half, it's simpler to write it as a multiple of 2. Is this clear?
Yes, sir.
What about this one? How do we integrate this?
E power 7x plus 4 upon 7
Well done. Incomplete. If you
plus
do
c.
not tell me plus c, the solution is wrong. It's incomplete. What about the next one? E to the power 5 minus 2x divided by negative 2.
Negative 2 plus c.
Again, I can just write it as e to the power 5 minus 2x upon 2 plus c, because writing a negative sign with the denominator doesn't suit us for further simplification. So we'll give the entire fraction a negative sign. Is this clear?
Yes, sir.
We can either take this 1/3 outside the integral or we can keep it in the integral as well. E to the power 6x minus 1 Now I need to, there was already a 3 in the denominator, and I need to divide it by 6 as well. So if multiple things have to divide, they multiply with each other, right? We did the same thing in basic algebraic differentiation as
Yes.
well. So upon 18 plus c. Is this clear?
Yes, sir.
Another technique was you could have kept 1 over 3 outside the integral, integrated the entire thing, and then multiplied by 1 over 3. Both were right. Is this clear? Let's move on to number 2. How will we intend to integrate this? What about the first one?
The e power x will be e power x
First, what do we have to do?
expand.
Obviously, we cannot integrate because we haven't studied a product rule in differentiation, or sorry, integration. And when you multiply e to the power x with e to the power negative 2x, two things are multiplying, their powers will
Add,
add up. Well done.
and then sir it
In
will
cases multiplied, powers will be add up, the power will become 3x. Now, can we integrate it? What will be the integral now? 5e to the power x minus e to the power 3x upon 3 plus c. Is this right?
yes, sir.
Okay, what about the second one?
So we will also expand.
Okay, how will we expand this? We can either make two brackets, or if we are familiar with a plus b whole square, we must do that, but most of you end up making an error while doing so. So I'll just take the saver option for you people. Yes, that is a better and a quicker way, but do not end up making an error. Now, e to the power 2x multiplied by e to the power 2x, what will it become? Yes, Vijay.
So e to the power 4x
Well done. Plus, and again e to the power 2x 2 times, so 2e to
plus
the power
2e
2x.
2x plus 1.
Remember, I haven't yet integrated it. Now what? Until the time I do not integrate it, I need to keep this integral sign and this dx on, because this is telling me that I need to integrate whatever is inside this. So what will I get now?
Say e to the power 4x upon 4
Well done.
plus 2e to the power 2x upon 2
Well done.
becomes 1 plus 1
Hmm.
upon x.
No, one has no,
1x, sorry. Not a,
yes, one has x to the power 0 with it. Do not forget the algebraic integration.
yes, sir.
One has x to the power 0. So when I increase the power of x, it becomes x and then plus c. Is this clear?
Yes, and then 2 becomes, simplifies to become 1.
Very good. You can write it as e to the power 4x upon 4 plus e to the power 2x plus x and then plus c. Well done. Okay, what about the next one?
So if here we also expand first
Okay.
using
A plus b whole square,
a plus
or
b whole square.
so, but be very careful. If you're using a plus b whole square, a square plus 2 a, sorry, a b and then plus b square. Is this clear?
Yes, sir.
So what do you get when you square it? 9e to the power 2x plus 6. And what is the final power of e that you get? Same basis when they multiply, the powers add up. So what is the power of e that you will eventually get?
Negative 2 minus x.
What about, I'm talking about this one, the middle term? I have e to the power x.
e
Add a negative x.
plus 0.
Yes, e to the power 0. And what about this one? E to the power negative 2x.
So why don't we just write 6 instead of e?
We'll write that. We'll write that. I was just confirming. I was asking you what should you do? What power should you get? So 9e to the power 2x plus, yes, 6e to the power 0 is a 1. The value is 1. And plus e to the power negative 2x. Okay, now can we integrate it? 9e to the power 2x upon 2 plus, what about 6?
So 6x
6x plus e to the power negative 2x upon negative
negative
negative 2
plus c.
plus c. Well done. Do not forget c, and then negative sign doesn't look well with the denominator plus c. Is this clear?
Yes, sir.
Okay. Now let's attempt question 3. Okay. I'll do the first part and I expect you to attempt the next one on your own. Okay. What step do you do in the first one? That is 2e to the power x. And now x will have to be brought up and the power will be negative half. Right?
Yes, sir.
Now can you integrate it? So 2e to the power x plus, what about this one?
X to the power 1 upon 2
Very good. Increase 1 to the power n
on
by
1
half
upon 2.
plus c. So 2e to the power x plus 2 under root x and plus c. Is this clear?
Yes, sir.
Well done. So attempt the remaining 2 and then I'll discuss. Okay, what are we doing in part C? First, we intend to write everything separately. Because we haven't studied any product or quotient rule for integration. There won't be any. Can I do this in this one?
Yes, sir.
Now, what do I get? X square cancel. What am I left with in the first part? इसमें क्या बच रहा है मेरे पास? Be careful when the power is in the variable e to the power 2x minus the power subtract only 2x में से x. If you remove, what do you get? Is this what you're getting?
Yes, sir.
What about the next one? Is this right?
So why did okay we shifted the x minus 2 power. Okay, sir.
We eventually have to, right? Because if it's in the denominator, we cannot integrate it, right?
Yes, sir.
Now, e to the power x upon 4. What about this one? What about the algebraic part?
X minus 1
Well done. And it will divide by
in negative 1
plus c. So
plus
just to make it look better, plus 1 upon 3x plus c.
so minus 1 upon 3x.
Now see, this is a negative 1 and this will become a
Oh,
negative 3,
okay,
right? So the entire fraction will get a sign of a positive. Is this clear? Is this clear, bache?
Yes, sir.
So now what about this one? The curve is such that dy by dx is this. How do I get the equation of the curve once it has provided me with the derivative? I'll simply integrate it, right? What will I get once I integrate it? E to the power 2x minus e to the power negative x plus c. Now, how do I figure out c?
So you put the coordinates of x and y.
Very good. Four is equals to 1 minus 1 plus c. So the value of c is 4, y is equals to e to the power 2x minus e to the power negative x plus 4. Is this clear now?
Yes, sir.
See, if I were to solve this one, I'll say, okay, first the question told me that the gradient of the curve is 1, dy by dx ki jagah I can just plug in 1, when the x coordinate is 2 plus 4 times 2. So 1 is equals to k, e to the power 0 is the value 1 plus 8. So 1 minus 8 is equals to k. So the value of k is negative 7, right?
Yes, sir.
Now I can say I'll get y once I integrate dy by dx or the derivative. So I need to write k is negative 7 e to the power 2 minus x plus 4x with respect to x. So I'll get minus 7 e to the power 2 minus x divided by the derivative plus 4x square upon 2 plus c. So y becomes equals to 7e to the power 2 minus x plus 2x square plus c. Now how do I get c? I can plug in the value 10 in place of y and 2 in place of x. So the value of c is 10 is equals to 7 plus 8, right? Plus c, so the value of c is negative 5. Y is equals to 7e to the power 2 minus x plus 2x squared negative 5 is the answer. Is this clear?
Yes, sir.
Okay, can we do the last part as well? Last question, I believe, and then we have two more questions. What if the question has given us a double derivative? Then what? What do I get once I integrate the double derivative or the second derivative? What do I get?
Dy by dx.
Well done. I'll get dy by dx. So how do I write it? I'll get dy by dx once I integrate this entire thing with respect to x. Is this right? So let's integrate it. What will we get? 8e to the power negative 2x divided by negative 2 plus c. Is this what you're getting?
Yes, sir.
Sure.
Yes, sir.
Okay, then the question tells us that dy by dx is 2 when x is 0. So in place of dy by dx, I can write 2 when x is 0. So 2 is equals to negative 4 plus c. c is 6. So my dy by dx becomes negative 4 e to the power negative 2x and plus 6. Is this right?
Yes, sir.
Okay, now how do I get y?
So we integrate it.
Absolutely right. Once we integrate this entire thing, so technically we have integrated it twice. And if you would have missed out on the first constant, your second integral would have been wrong. Now, do you understand the importance of plus c? What will be the integral of 6?
So 6x.
Well done. How do I find this c? In place of y, I'll just put 2 over e square 2e to the power minus 2 times 1 plus 6 into 1 plus c. So 2 over e square is equals to 2 over e square plus 6 plus c. So it subtracts 2 over e square cancelled out. C is negative 6. Y is 2e to the power minus 2x plus 6x minus 6. Is this the same value that you're getting? Same function, same equation? Yes, Bache?
Yes, sir.
Gonna
This is
and the last one quickly, then we will discuss it. Okay, first, we cannot get the value. The question is told us that Q lies on the curve, right? That's the entire information we have. We cannot find the value of K unless we have the equation of the curve. So first, we will have to make the equation of the curve on our own, and we know if we are provided with the derivative, we can simply integrate it to get the equation of the curve. So 2e to the power 3 minus 2x divided by a negative 2 plus c, right?
yes, sir.
So I'll just plug in the values of p. In place of y, I'll write 5 minus e to the power 3 minus 2 into 3 over 2 plus c. So I guess this becomes 0. 5 is equals to minus 1 plus c. Do not put the entire thing as zeros. The value of c is 6. So now I have the equation of the curve 3 minus 2x plus 6, and the value, it's a negative here. Okay. So now you can just plug in the values of q. Because I know it lies on the curve, so it must fulfill the equation of the curve. Y coordinate is k, and the x coordinate is 3 minus 2 into 1 plus 6. So if the question would have asked the exact value, which it often does in the past papers, so E will remain E as 6, and you can leave the answer of K as 6 minus E. This is called the exact value of K. It is often asked in the past papers as well. So once exact value is asked, you leave your answer as it is. Is this clear?
Yes, sir.
This is part 1 done. Now the question is asking us the normal to the curves at point P and Q intersect and the point R. How do we do this? First, we make the equations of the two normal, right? So first, let's talk about the normal at P. Is this clear?
Yes, sir.
How do I get the equation of straight line? I need two things. I need a point and I need the gradient. So I can find the m of tangent at P. How do I find the m of tangent at P? If I plug in the value in dy by dx, e to the power 3 minus 2 into. So the gradient of tangent is at P is 2. So what will be the gradient of normal at P? Negative half. Now I already have the coordinates of P. Y minus 3 over 2 is equals to negative half x minus 5 using the gradient point method. negative half x. We can leave it as it is as well, but just to help you understand, 5 over 2, 8 over 2, negative half x plus 8 over 2 is 4. Is this clear? This is the equation of normal at P. Is this right? Anything that not understood till this point? Yes, bache.
Sir, I understand.
Okay, that was at P. Now we are talking about at Q. So M of tangent can be found by plugging in the value of Q, which is 1. So 2e to the power 3 minus 2 into 1. So the value of the gradient is 2e. So the gradient of the normal will be negative 1 over 2e. Now I can simply make the equation y minus y1 is 6 minus e is equals to gradient into x minus x1. Is this clear?
Yes, sir.
Now I can simply plug in this in place of y and solve the entire thing to get the coordinates of r. I only have to solve these two equations simultaneously, and the simplification entirely depends upon the method that we choose. Is this clear?
Yes, sir.
Now simultaneously solve them to get the coordinates of r.